This is a review of our classwork 3.1. Review of classwork 3.1. This is in preparation for your quiz Friday, or for those of you who are absent Tuesday, a review for your quiz Thursday. Our first objective is graphing using intercepts. So we need to be able to find our x-intercepts and our y-intercepts. First thing you want to do is make sure you have your notebook paper and pencil and calculator. We're going to start by finding our x-intercept. And remember, look back in our thinking, our x-intercept lives on the x-axis here. And on the x-axis, notice anywhere on our x-axis, the one thing that's true of every x-intercept on the x-axis is our y value is always 0. That means if we're given an equation, we can always find our x-intercept by setting our y value equal to 0. So we're going to take our standard form equation, 7x minus 2y equals -14. And since our x-intercept is the x value when our function crosses the x-axis, so it lives on the x-axis, and on the x-axis our y value is 0, we will substitute or evaluate where our y value equals 0. So we will evaluate for y equals 0. And then by substitution property of equality, 2 times 0, or -2 times 0 is 0. And since we're doing 7x plus 0, that's just 7x is negative or equals -14. And then we are trying to find that x value. That's what our x-intercept is. And we have a problem with our coefficient here. We're going to do our inverse operation, or multiplicative inverse, divide each side by our coefficient of 7. We'll divide both sides by 7. 7 divided by 7 is 1. So x equals -14 divided by 7 is -2. So my x-intercept is -2, or the place where my x-intercept lives on the x-axis is at -2. This is where my relationship, where's my graph, where my line will cross the x-axis, is at -2. So that was my x-intercept. This is the work that you should show for your quiz. Your quiz will have a written part. You need to write all of that down on your piece of paper that you will turn in at the end of the quiz. And that is half of the credit for your quiz, is showing that work. Then we need to find our y-intercept. So our y-intercept is the y value where our function, our graph, our line crosses the y-axis. And that's going to live on the y-axis. And the one thing that's true about any y-intercept, every y-intercept, is that its x value is always 0. The x value here is 0, the x value here is 0, and the x value here is 0. So we're going to set x equal to 0. So we can take this standard form equation, x 7x minus 2y equals -14. And we can use our substitution property, or we can evaluate for x equals 0. We say, what is the y value when x equals 0? Since we want to find the y value, in this case, we're going to solve for y and get y by itself and positive. We're going to isolate the y. By substitution property of equality, 7 times 0 has a value of, or evaluates to 0. And 0 plus or minus anything is itself the other thing. So now we have negative 2y equals negative 14. And when trying to get y by itself, we still have this coefficient of negative 2. So we're going to use a multiplicative inverse of negative 2. Multiplying by negative 2 is dividing both sides by negative 2. And negative 2 divided by itself is 1y. And a negative divided by a negative is a positive. 14 divided by 2 is 7. So my y-intercept is y equals 7, which means that the place where my graph crosses the y-axis is at positive 7, or we could think of this as a height of 7. And this now graphs. This is the picture of this relationship, the relationship between this x value and this y value, and any one of these points will make this equation true. All right, and this is the other half of the work shown for this problem. All right, go ahead and make sure you've saved that answer and plotted your x and y intercepts before moving on to number 2. Okay, so number 2 is going to be much the same. Go ahead and take a moment and try this. And then I'm going to show you the correct answers, and then I will briefly work through them so you could check if you got something wrong and see if you could see why. If you're working this, hopefully you started your x-intercept first, because that's going to be the first one I show you the answer to. You should find an x-intercept of x equals negative 10. You got that correct? Great. If you're still working, go ahead and continue that. Confirm to see if you got that correct. If you've finished it, go ahead and move on to your y-intercept. A quick demonstration of finding our x-intercept this time. Our x-intercept will be where y equals 0. So I'm going to take my 3x. Negative divided by a positive is negative. And if you have found your y-intercept and are ready to check that, you can check that up here. I'm not going to say it out loud this time. You should get a y-intercept of y equals so you can check that on the board now. got that correct, great. If not, you can check your work against this here. Remember, a y-intercept lives on the y-axis, where x is always 0. So we're going to take that equation, set x equal to 0. You can check your answers and your work against that. This together makes up appropriate work to get full credit on a question, other than the graphing, which our x-intercept is on our x-axis. That's the x-intercept is where the graph crosses or touches the x-axis. In this case, that is at x equals -10. The y-intercept is where the graph touches the y-axis. Since it's -6, it's going to be down underground. -6 crosses the y-axis. So make sure you've graphed that before we move on to number 3. Okay, so moving on to number 3, I want to be clear again, there is some specific required work to show for your quiz. We are completing the table and then graphing the function. On IXL, there's completing the table, graphing the function. On your piece of paper, you do need to show also writing out and filling in your frame. So when we say the frame, that is this right here with parentheses in place of the x, so 2 parentheses plus 4, 2 parentheses plus 4, 2 parentheses plus 4. If you skip this part and do not show your work on the paper, you are looking at half credit at most for this problem. So make sure for this quiz, you need to take this extra step. For the test at the end of chapter 3, you'll need to take this step, and then never again after this point. Once you move on to chapter 4, if you want to skip showing this work and you just fill in the table, that's fine. But at this point, to make sure we all fully understand this process, it's required. And the last part is filling these x values into the parentheses so that this x value of 1 goes in here, that this x value of 2 goes in here, and that this x value of 3 goes in here. So that is our shown work requirement here. And then we're going to evaluate these. Now this part that I'm going to show on the right here, this is optional. If you ever struggle a bit, it's recommended. If you have a really good calculator, you might be able to literally plug this as it is in your calculator and get a good answer out. If you're strong with your mathematical calculations, and you might just look at this and understand the answer, and that's fine also. But this is 2 times 1. Touching a number touching parentheses indicates multiplication, just like we used to use a little x to x1. But now we use x to mean a variable, so we don't use x to mean multiplication anymore. We use parentheses. So this is 2 times 1, which is 2 plus 4. This is 2 times 2, which is 4 plus 4. It's optional. This is 2 times 3, which is 6 plus 4. You don't have to show this part, but I want you to see it just this time so you understand what's happening. And then 2 plus 4 is 6. Oops, we're actually going to fill that in. You can type it in. 4 plus 4 is 8, and 6 plus 4 is 10. So you're going to type those answers in to the IXL to actually get credit for them. And then we need to plot each of those points. I'm going to copy them down here so I can see them when I scroll my grid up. Remember that this is my x value, which is positive is to the right, negative is to the left. This is my y value. Positive is up, negative is down. So these are coordinates on a grid. This is saying an x coordinate of 1 and a y coordinate of 6. This spot is where my x coordinate of 1 intersects with my y coordinate of 6 right here. And this is an x coordinate of 2 with a y coordinate of 8. This is an x coordinate of 3 with a y coordinate, x coordinate of 3 with a y coordinate of 10. This is where those two coordinates intersect right here. And any two of these points will define that line. You'll see that this point right here will fall, this coordinate of 2, 8 falls on that line. So you can plot any two of them and it will come out correct. So make sure you've graphed that line and then we can move on to number 4. So number 4, and you will have one on your quiz that will have a fraction. This review assignment is set up to be designed to be essentially just like what you'll see on the quiz. If you've worked through this, listened to this video, rather than just watching the subtitles and follow along, you will feel fully prepared for the quiz if you make sure you fully understand this assignment. And you will have a question like this with a fraction on your quiz. So we're going to start with our frame. In this case, negative 3 over 5, parentheses for our x, minus 4. And we have this 4 times. I'm going to split it up because the fractions take up a little bit more space. Negative 3 over 5, parentheses, minus 4. Negative 3 over 5, parentheses, minus 4. And I'm going to do this for 4 different versions of x, which are negative 5, 0, 5, and 10. If you have a calculator that handles fractions, this is super easy. You can literally plug this exactly as you see it in your calculator. If not, if you're using one of the classroom calculators, you will, anything on the top of a fraction is something you multiply by. Anything on the bottom of a fraction is something you divide by. So if I were putting this in a classroom calculator, unfortunately the calculators, you have to put the sign in last. So I'm going to put this in my calculator, 3 minus, because this is on the top. And then I want to divide it by 5. And then I'm going to multiply, because this is not in a denominator, times 5 minus, because it's a negative 5. Now, all my multiplication and division I'm going to do together and hit equals. So I need to pause. That's kind of a pause. And get that result. Then I can subtract. This isn't a minus. This is a subtract 4. And hit equals. That should give you your correct answer. If you are strong with your fractions, you don't even need your calculator. We could look at this and recognize this 5 in the numerator will cancel with our 5 in the denominator. And 5 divided by 5 is 1. A negative times a negative is going to be a positive. And I'm left with 3. So it's just positive 3. 3 minus 4 is negative 1. So that's also an option. In this case, anything times 0, oops, I'm a little too far there. Let's grab our eraser. Anything times 0 is 0. 0 minus 4 is negative 4. Here, we have a 5 in the numerator and a 5 in the denominator. 5 divided by 5 is 1. 1 times negative 3 is negative 3. Negative 3 minus 4 is negative 7. And I now see a pattern. I might predict and guess, I think this might be negative 11, but I do still need to write out this frame at minimum for the full written credit. And I recommend still using your calculator or calculate this out to verify your prediction. 10 divided by 5 is 2. Negative 3 times negative 2 is negative 6 minus 4. Ooh, in fact, I did predict wrong because I have a headache. This prediction should have been negative 10, so my prediction was wrong. Negative 6 minus 4 is negative 10. So my prediction was wrong. The correct answer is negative 10. So to graph this, I'm going to graph any two of these points. I'm going to choose negative 5, negative 1, and 0, negative 4. I like to graph something with a 0. That's a reminder that this is an intercept. Since x is 0, my y value is negative 4. This is a y-intercept. It's going to be on my y-axis at negative 4. And then I have the point that is the intersection of x is negative 5 and y is negative 1. And here's my graph of this equation. And I'll also see, and I can double check that my graph is correct, my other 2 points should also be on this line. So 5, negative 7, and 10, negative 10 should also show up on this line. So I could double check this. 5, negative 7, that's on the line. Oops. And 10, negative 10 is also on that line. So that's a way to check my answer. All right, we will move on to number 5. Those are the longest problems, 1 through 4. The rest go a lot faster. So, linear or nonlinear, there were a few things we came up with to help us remember here, and you might like to add these to your notes just as ways to remember, especially with fractions. Oftentimes we think fractions are always a problem. First of all, when going linear versus nonlinear, do not confuse this with standard form. This is it's all about the variables. I don't care about the numbers. Having decimals or fractions that are just numbers is not a problem. Having a 7.5x is totally okay. But having x to the 7.5 power, that's a problem. So linear versus nonlinear is all about the variables. But here's the things about our variables. Our variables need to be x or y. They need to be on their own, not multiplied to each other. They can be added or subtracted to each other. They can be equal to each other. That's fine. They cannot be times or divided by each other. And they need to just be to the first power. And then I've described this as nothing hinky, okay? So there should not, here's all the, you can think of this as the naughty list. The naughty list. This makes them non-linear. Okay, no radical variables, no fractional power variables, no decimal power variables, no variables as an exponent. Like we're not dealing with any of these things yet. This is like almost all Algebra 2 stuff. That's kind of the thing. Okay, these are all bad. No negative exponents or even x to the negative 1. These are all naughty. And most of you, and not even like x squared, because we just want it to be to the positive 1 power. And you guys are really good about recognizing that all of these are bad. The one that trips you up is when we just have x to the 1 power, but there's fractions involved. And here's why. We could have x over 2, and we could have 2 over x. Are these linear or nonlinear? Are they both linear? Are they both nonlinear? And why? And here's a little saying we came up with to help remember. Okay? The problem is not that there's a fraction. Fractions by themselves are okay. The problem is, where is the variable? And we came up with this to help us remember. Numerators are nice. So this is okay. This is linear. And x in the numerator is okay. That's just x to the 1 power. We're just saying it's half of an x. It's 0.5 of an x. That's okay. That's fine. It's still x to the first power. Deny the denominator. Oops. No, did it erase all my work? No. Okay. Let's go back. Deny the denominator. This is bad. Bad. Okay, x not good for this. Back it up, because x means things. 2 over x with a circle, with a single cross. Okay, x in the denominator is non-linear, because x in the denominator technically means x to a negative power. And we'll learn that later. So it's a little bit of a pain that we teach this now. It's how the curriculum is set up, and maybe in the future we'll just take this out. But for now, we've started it, so we're going to finish it. If our x is in the denominator, if any variable is in the denominator, it is non-linear. It's being in the denominator that is the problem. Being in the numerator is okay. Jose, it is fine. All right. So for these problems on your quiz, you need to use an explanation. You'll have to write 3 to 5 words of why it's linear or nonlinear. Don't just say it's linear or it's nonlinear. Say the variable is in the numerator, or numerators are nice. Say the variable is in the denominator, or deny the denominator. Those are both fine ways to give your explanation for why it is linear or nonlinear. In this case, for number 5, the x is in the denominator. You could say x is in the denominator. You could say variable is in the denominator. You could say deny the denominator. Write any of those on your piece of paper and you get full credit. In any event, this is nonlinear, so we can mark that and move on to our next question. Number 6, is this function linear or nonlinear? Well, do we have any of our obviously naughty issues? Do we have variable in the radical? Do we have variable in the exponent? Do we have a variable with a negative exponent? Do we have a variable with a fractional exponent? Do we have a variable with a squared or cubed exponent? None of those. So we do have a fraction. Is our variable in the denominator? No. Is our variable in the numerator? Yes. Is the numerator a problem? Numerators are nice. You can write that down as your written work. Numerators are nice. This is linear. Numerators are nice. So it's linear. And we can move on. Okay. Is this function linear or nonlinear? From graphs, it's linear if it represents a single straight line. Does this represent a single straight line? Yes. You could just say it represents, or just say represents single straight line. We still need to give our explanation here. A single straight line, yes, it is linear. It gives us a single straight line. And then we can move on. Is this linear or nonlinear? No, it is nonlinear. Why? You could either say it's not a straight line, or you could say it's curved. Okay? It's curved. You could say it's not a straight line. Either way is fine. Number 9. Is this linear or nonlinear? Everybody say it out loud. Go. Sub. Did they say it? If not, make them say it. Okay. No, nonlinear. It's curved. So we'd write down it's curved, or we could say not a. Remember, single was important. Single straight line. Single was important because sometimes we have more than one straight line, but to be linear, it has to be a single, nonlinear, single straight line. Okay, number 10. All right, so this is more x and y intercepts. This time we're not graphing, we're just finding. But what we're going to see in 10 and 11 is that in these problems we might get fractional answers that need to be represented as fully simplified, so no common factors between the numerator and denominator, proper or improper fractions, so no mixed numbers, no decimals. We do need to show our work here just like we did for numbers 1 and 2. So again, remember our x-intercept lives on the x-axis where y equals 0. Go ahead and take a moment. This is review, so this is a good chance to try this. Try finding your x-intercept. And I will write the answer up in just a moment so you can check. Okay, and then our y-intercept is on the y-axis where x equals 0. So try finding your y-intercept and then check your answer on the board. If you got either of those wrong, I'm going to show the work real quick so you can check your work against my work. This is the minimum amount of shown work. We need to actually show the step where we substitute in 0 for y. Don't skip that. That is showing our understanding of the concept. And showing the steps of our algebra also helps us for our own error analysis and if we are getting help from someone else to help us analyze our errors. So here's the work for our x-intercept, here's the work for our y-intercept. Okay, and our answer's boxed, so they're clear and easy to spot. All right, if you need to raise your hand, ask the sub to pause while you share your work with someone. If you still haven't found the correct answer, have someone nearby look over it with you and help you spot where you might have missed something. Go ahead and take that time. You're going to have plenty of time. We are almost done. The last 4 questions go really fast. Okay, we're going to move on to number 11. Same as last, except now we're going to see some of these fractional answers here. Go ahead and try this. I'm going to write the answers in so you can check to see if you got them correct. And then I'll show you the steps so you can error analysis your work. Okay, the answers are up for you to check. Even in class, even with this practice, even though I'm not collecting your work, be practicing showing this work right now in class. Don't fool yourself into thinking I can skip doing the work in class, but then I'll magically know how to show it correctly on the quiz. That's not what happens. Practice with this time in class, that's what it's for. If you want to do it in your head first and then show the work, fine, but go through the process of showing the work. The way I'm telling you, I want the work shown so that when you get to the quiz, you're not suddenly blanking on how to show the work. That's worth 50% of your grade, because I have had students get 100% on getting the answers correct and then show 0 work and get an F on the quiz, because the work is worth 50% of the grade. All right, so make sure that you are practicing this part in class right now. Here is our work shown for the y-intercept. I'm going to talk through this last part now, and I'm going to rewrite this last part a little bit better real quick. So at this part, I'm looking at this. I have 16 divided by -10. And we could have some questions, well, what do I do with this negative in the answer? First of all, I have a positive divided by a negative, and a positive divided by a negative is negative. So the answer, the sign of my answer is negative. I start with that. Then I have 16 divided by 10, which is 16 tenths. Okay, so I have a negative in front of my fraction. But then this fraction needs to be reduced. I need to cancel out any common factors. And what is the largest number that I can divide both of these by? And I can divide these both by 2. And what's happening is I am basically multiplying this by 1/2 divided by 1/2, which is multiplying it by 1. And because anything divided by itself is 1, and I can multiply anything times 1 and it doesn't change its value. That's what happens when I reduce a fraction. So again, this is a negative, and 16 divided by 2 is 8, and 10 divided by 2 is 5. So as a properly written fraction, this is negative 8/5. When I have an answer space that I can write this as a properly written, it's called a stacked fraction, where the numerator is on top of the denominator, then the proper way to write it would be with the negative in front, the numerator on top, and the denominator on the bottom. But if I don't have that option for whatever reason, then we put the negative in front and then the numerator slash the denominator. And the reason is, if I instead wrote 8/-5, this might be confusing and look like I was maybe trying to subtract. So we do not do this. We make sure our negative is in the front, so it's clear that it is telling us the sign of our number, the value of our number, rather than an operation on our number. Okay, so I just want to clarify that. And that is our fully simplified proper, or in this case, improper fraction. Again, if you haven't spent that $15 on your fraction calculator, you want to do that as soon as possible. It will just simplify this whole process for you a lot. We're going to move on to 12. We are in the home stretch and about ready to go on break if you are doing this in class. Our last piece here is writing the equation of a line, and there are a few different ways to look at this. If you haven't completed the notes from the, it was 3.1, maybe, I'll have to look. I think it was 3.1D, but we had a set of notes that can be really helpful here, but I'll look at it conceptually with you as well. But there was a set of notes that you were supposed to watch a 5-minute video that talked about HOI and VUX as a set of acronyms to help you remember horizontal and vertical lines that basically said horizontal and vertical. I'm running out of steam, guys, sorry. Horizontal lines are y equals equations with a zero slope, and vertical lines are x equals equations with an undefined, which we'll talk about slopes later, in a very soon lesson. Y equals equations and x equals equations. So this is a shortcut to help you, in which case we'd look at this. And also, if you struggle with, is this line vertical or horizontal? Couple things to help you. I sometimes just draw like horizontal, just kind of think of like this mustache on the H. Horizontal goes across. Vertical, you can kind of draw some arrows up and down. Vertical goes up and down. So I'd look at this and go, oh, this is vertical, so it's an x equals. Another way, if you think about when you're looking out across the horizon, maybe you're on a boat, all right, and you're looking at the horizon, that is the horizontal line between the sky, where the sky touches the ground or the ocean or whatever it is. That is the horizon. That is also the horizontal. It is the horizontal line. A vertical line is like a flagpole, goes up and down. It's a vertical. So a couple things to help you with that. Okay. But looking at a graph, we can also connect and go, what's the equation of this line? Well, what are some values of some of the points here? Maybe just grab a point. This point has a coordinate value of, this is an x value of 1 and a y value of 4. And here's another point. This has an x value of 1 and a y value of 1. And here's a point with an x value of 1 and a y value of -5. Well, what do we notice is common in all of these different points? In every case, the x value is 1. So we could say we could describe this line as x equals 1. Could also say that this is the line that passes through the x-axis at x equals 1. We could say it is a vertical line that passes through x equals 1. So that's several different ways to kind of look at this line and recognize it is a vertical line that could be described as all of the points that have a value of x equals 1. Okay? Whereas number 13, we look at this and go, oh, well, if I looked at some points, here's, this has an x value of -5 and a y value of 9. And here is an x value of 0 and a y value of -9. And here is an x value of 4 and a y value of -9. So I see that what all of the points I've looked at on this line have, sorry, not -9, just 9. plus. What all of the points on this line have in common are y values. Oh, not letting me draw all of a sudden. Okay, sorry about that. Y values. Nope, still giving me problems. Okay, y values of 9. Is it fixed? Nope. Okay, this will be weird going into the end here. Here we are. Y values of 9. So I would say this is, all right, y equals 9. And we'll go with y. Y equals 9. Very weird kind of cursive. Let's try to skip and see if that fixes it. All right. All right, then our last two questions. Is this graph the equation of a horizontal or vertical line? So we could try graphing this and see. This is x equals 4. Well, okay. What would be some places where x would equal 4? Here's a spot with a value of 4, 0, and here's maybe a spot with 4, 3, and maybe here's a spot with 4, -1. What happens when I connect these points? What kind of line is that? Well, that is a vertical line. Another way, again, is our Hoy Bucks, which tells me if I have an x equals, it is a vertical line. And then finally, for number 15, this gives me y equals, so if I tried graphing some points, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. If I tried graphing some points where y was 6, then that would be like 0, 6, and 4, 6, and -6, 6, and I'd see if I connect those points, I get a horizontal line. I could also look at my Hoy Vux and see that when I have y equals, that gives me a horizontal line. So those are two different ways to look at that type of question. So if you are in class and are just completing this, after your break, you're going to have an opportunity to work a independent practice version of this, basically a practice quiz. When you submit it, you will get to see your results and look back over, see what you got wrong, look at those and see if you can figure out what you got wrong. And if you are doing this because you were absent, I will put that up also, but it will be for period 2, that will be an something that will not be assigned until class on Thursday, so you're not going to, so actually you won't see that until class Thursday. So that is it. Thank you guys very much. Make sure that after you've answered everything, you hit submit quiz. Thanks.